We are going to calculate the x bar for the area of the circular segment, knowing that the area A1 is a circular sector for which the x1 bar equal to 2/3 of A sine theta divided by theta, and the area A2 is triangle for which the x2 bar is 2/3 A cosine theta, and for that triangle we have axis of symmetry. That is why the CG lies on the x-axis. So we'll proceed by multiplying A1 x1 and deduct A2 x2. For the A1 x1, the A1 is A squared theta, and the x1 bar is 2/3 A sine theta over theta. So we have 2/3 A cube theta will go with theta. We left with 2/3 A cube multiplied by sine theta. What about A2 x2 bar? The A2 already we know it is A squared sine theta cosine theta multiplied by 2/3 of A cosine theta. So we have A cubed and 2/3 outside. We have sine multiplied by cosine square. So we are going to deduct now 2/3 A cubed multiplied, we open bracket, we have sine theta minus sine theta cosine square theta divided by the net area, which we have already estimated as A squared of theta minus sine 2 theta over 2. We will make more modification by taking the sine theta outside. So what is left is 1 minus cosine square theta, and we know that sine square theta is equal to 1 minus cosine square theta multiplied inside theta again. So we get 2/3 A cube over A square divided by bracket of theta minus sine 2 theta over 2. This sine theta by sine square theta will give us sine cube of theta. In the textbook or the manual, he just removes the expression of sine 2 theta into 2 sine theta cosine theta, and in order to cancel the 2 and 2, that's what happened, and then he gets the expression of x bar equal to 2/3 A sine cubed of theta divided by bracket contains the theta minus sine theta cosine theta. Now we will move to new topic, which is the ellipse. Our ellipse, if the ellipse is, the center of the ellipse is at the intersection of x and y axis, then it could be represented by the equation of x squared over a squared plus y squared over b squared equal to 1, where is a is the major axis distance along x-axis, and the b is the minor axis distance along y-axis. If we are going just to rotate this ellipse 90 degrees, the equation will be changed into x squared over b squared plus y squared over a squared equal to 1. From that equation, we can get another expression for y squared, that y squared over b squared equal to 1 minus x squared over a squared. And we can move further by multiplying b squared. We get y squared equal to b squared multiplied in bracket, which is 1 minus x squared over a squared. And we can get the square root of this calculation, y equal to b, the square root of 1 minus x squared over a squared. What about the CG? The CG will be at the intersection of x and y. We have x as axis of symmetry. Upper portion, the two areas above x equal to the two areas below the x, and similarly for the y-axis, these two areas similar to the two areas at the left of axis y. In order to estimate, and since they are all symmetrical, we can start use 1/4 and by using the strip method, for which we take dx multiplied by y, and this dx strip is apart by x distance from the y-axis. So our area, we can say it is for the integration of dA equal to A. For this small strip A, we are going to integrate it from 0 to A, because we are integrating in the x direction. So we left with y by dx. Already we have the expression of y, which is b multiplied by 1 minus x squared over s squared. If you combine the a squared here, it will be a squared minus x squared divided by a squared, takes the square root of a squared. We get it out, so our y will become b over a multiplied by a squared minus a squared. All these brackets will take the square root of it, and we multiply it by dx. But again, we are going to introduce a parametric equation, and we are going to use the parameter of theta to facilitate the calculation. What is a parametric equation? Actually, we know that y is a function of x. If we introduce a new parameter, we call it theta. We are going to give a relation between the parameter theta to x and y, so that x will be a function of the theta, as well as y equal to the function of the theta. Now, in order to let that expression fulfill our requirement, we'll assume that x equal to a cosine theta, and we check the various values of theta and the corresponding value of x, and we check it in our ellipse to see what's going to happen. For theta equal to 0, and our theta, by the way, is the angle between x and y, and the connection is x and y. So when this theta equal to 0, this is supposed to give the x distance equal to a. And when theta equal to 90, it's supposed to give the y-axis equal to b, at the same time the x value equal to 0. We are going to correct just this one into 0 and b, because the x distance will be 0 and this will be b. So check now, cosine 0 equal to 1 multiplied in a, we get a. For the theta pi over 2, the cosine pi over 2 is equal to 0. That's why we get that point when theta equal to pi over 2. Check again when theta equal to pi, we're supposed to get a equal to minus a and 0. And that's what happened. Cosine pi equal to minus 1 multiplied in a, we get minus a. If you want to move further to 3 pi over 2, we will get minus a. So for 3 pi and 2, we get 0. But while for 2b, we get again, for the 2 pi, we get again the value of a. That's fine. Our next step is to develop expression for the y. By using the equation to get an expression for y, we know that y squared equal to b squared multiplied by 1 minus x squared over a squared. Since we are saying that the x is equal to a cosine theta, so the x squared will be a squared cosine squared theta divided by a square. A square will go as a square, and we left with b squared multiplied by 1 minus cosine squared theta, which is b squared sine theta square. In order to get an expression for the y will be b sine theta. Again, we are going to check the values of theta and check against our ellipse to check we are right or wrong. If theta equal to 0, then our y value will be equal to 0, which is true. For theta equal to pi over 2, we get the sine equal to 1 multiplied in b, so we get b here. And for theta equal to pi, we get sine pi equal to 0. That's why our y equal to 0 by b equal to 0. At the end, when theta equal to 2 pi, then sine 2 pi would be equal to 0, and that's why sine 2 pi this y will be equal to 0 for sine 2 pi. This is, I'm going to correct it. This will become 0. So by the combination of x and y, we will find that our parabola points are achieved. Now, after we're getting the expression of x equal to a cosine theta, and we know that our capital A is 4 times the integration of dA, which is y dx, integrated from 0 to a. So our y is b sine theta, and our dx, we have to differentiate the x. In that case, our dx will be minus a sine theta d theta. But we are going to take the absolute value of that one, otherwise the multiplication of the minus by the positive, it will become negative value, and we know, of course, that the area should be positive, so we are going to take the absolute value of that one. So we have a sine theta as dx, we have a sine theta d theta, and we multiply it by y, which is b sine theta, so we get ab sine square theta d theta, and we have the 4 outside. We get ab out, so we have capital A equal to 4ab, and we are integrating from 0 to pi over 2. Of sine square A d theta. We will use the expression of sine square theta, which is equal 1/2 1 minus cosine 2 theta. This will facilitate our integration. So we have the integration of 1 minus cosine 2 theta d theta. The integration of d theta is theta, and the integration of minus cosine theta is minus sine 2 theta over 2. And we are going inside the bracket. Here we will multiply 4 by 1/2 equal to 2. So we have 2ab, open bracket, theta minus sine 2 theta over 2. Substitute from 0 to pi and 2. So 2a and b, for sine 2 theta is sine pi. First, theta substituted by pi over 2 minus 0. We get pi over 2 minus 0. Then again this minus sine, put it here. And sine 2 theta multiplied by pi over 2 is sine pi, which is 0. And minus, again, the sine 2 theta of 0 divided by 2. Again, it is 0. So we left with 2ab pi over 2. This 2 will go with this 2. And we finally get the value of pi AB. That is the area of the ellipse, and for which it is similar to the circle, but for the circle we have both equal radii, while for the ellipse we have one radii A and the other is B. So we can say that the area equal to pi AB. Thanks a lot, and see you the next topic.